Hey, welcome to the Explainer. Today, we're diving into something huge. We're talking about a fundamental shift in how we actually create the software that, let's be honest, runs our world. It looks like the days of a developer painstakingly typing out every single line of code might be coming to an end. We are right on the edge of a brand new era, and trust me, it's going to change just about everything.
So that brings us to the big, kind of scary question on everyone's mind, right? Is the actual skill of writing code about to become obsolete? I mean, this question hits right at the very heart of the entire tech industry. And you know what? The answer is a lot more interesting than a simple yes or no.
All right, so to really get a handle on where we're going, we first have to look back. We need to understand the challenges that have been nagging software development for decades. This is what we'll call the old way of building things, and frankly, it was full of problems.
And if you've ever worked in tech, these pain points are going to sound super familiar. We're talking about this messy, tangled web of different systems that just refuse to talk to each other. A mountain of administrative busywork, and oh, the frustration of not being able to see your own data clearly. But it doesn't stop there. Making a simple update can feel like it takes forever. Trying to scale things up is a constant battle, and it's all built on this creaky old foundation of complex, outdated architecture.
And this right here, this is a perfect picture of what we mean when we say legacy architecture. It's like a map of all the complicated gymnastics you have to do just to get a new, modern system to talk to an old but super critical one, like a mainframe. These old systems are still the backbone of so many big companies, but man, they are a massive headache when you're trying to build for today's world.
So, all these challenges created this desperate need for a better, smarter way to build and integrate software. And that's where our first major evolution comes into the picture: low-code platforms. So what in the world is a low-code platform? Well, think of it like building with Legos, instead of, say, trying to write a novel from a blank page. You're using these pre-built visual components that you can just drag and drop to create your app. This approach is simple, but it's incredibly powerful. And it opens up the world of software creation to way more people than just the super specialized coders.
And when you put the two side by side, the difference is, well, it's night and day. Custom coding is slow, it's really expensive, and it demands a ton of expertise. Low code, on the other hand, is faster, it's way more affordable, and it's much more accessible. For businesses that need to move fast, this was a total game changer.
But hold on, you can't just throw a new tool at a huge company and expect everything to work perfectly, right? To do it right, you need something called a Center of Excellence, or a COE. Think of it as a central command team that sets up the rules of the road, the best practices, and the governance to make sure low code is being used effectively and securely across the whole organization.
So how do you actually build one of these things? Well, Mendix lays out this really clear three-phase plan. First, you start small. One team, one successful project. Just prove that the concept works. Then, you structure. You take that experienced team and break it up, spreading their knowledge around to guide a whole portfolio of new apps. And finally, you scale. This is where the whole organization has solid processes, automated testing, and is just humming along, delivering great software with low code.
But just as the world was getting really comfortable with low code, a new force emerged, something even more powerful: the AI Copilot. And this isn't just a small update. No, this is another fundamental shift in how software gets made.
And this quote from Anjali Arora, the CTO at Perforce, just nails it. She says, "The rapid rise of AI presents an exciting opportunity for your teams. Change." And she's not talking about a small tool update here. She's talking about a fundamental shift in skills, roles, and how we work. It's a big deal. Now, to get amazing results from these new AI tools, you need a new skill. It's called context engineering. This is way beyond just typing a short prompt. It's about feeding the AI a ton of rich information, giving it documents, maybe access to certain systems, telling it exactly what its role is. You do all this to get better results and to stop the AI from making things up, what they call hallucinations. This all leads us to a really mind-bending idea, one that builds on all this AI power. It's called vibe coding, and it's a vision of the future that completely flips the role of the developer on its head. Just picture this for a second. Instead of typing out code, you're basically just having a conversation with an AI. You describe what you want in plain English, and the AI just generates the code for you. Your job completely changes. You're no longer the writer, you're the editor, the director, guiding and refining what the AI creates until it's just right. The ripple effects from this are just massive. Entire steps in the development process, they'll just disappear. They'll be automated. Plain old English becomes the new programming language. And get this,
every single engineer basically gets promoted. They become a high-level architect, supervising a whole team of AI agents to build their vision.
Which, of course, brings us right back to that huge question we asked at the beginning. If an AI is writing all the code, is the human coder officially a thing of the past?
And the answer is a resounding no. Actually, it's the complete opposite. Those core software engineering principles, understanding good architecture, security, quality, they become more important than ever. Think about it. You can't be a good supervisor for an AI if you don't understand the fundamentals of what it's building. Human judgment is that critical last step that makes sure what the AI built is safe, efficient, and actually works.
So how do we get the incredible speed of AI while keeping the discipline and reliability of traditional engineering? The answer might just lie in our final concept for today: vibe modeling.
Now, the key difference here, and this is the key, is that with vibe modeling, the AI's output isn't a wall of code. It's a model, a high-level visual blueprint of the system that pretty much anyone can look at and understand. Once everyone agrees the model is right, then reliable, predictable tools take that model and generate the final code.
Here's how it works in practice. You have a domain expert, let's say someone from the finance department who knows their stuff but can't code. They just describe what they need to an AI agent. The AI then creates a visual model, a flowchart, that the expert can actually look at and say, yep, that's right, or no, tweak this part. Once the model gets the thumbs up, a code generator turns it into a real, working application.
Okay, let's put these two ideas head-to-head, because the difference is crucial. Vibe coding spits out source code. It's hard for a non-expert to check, and honestly, it can be a bit unreliable. It's great for quick prototypes. Vibe modeling, though, produces visual models that anyone can understand. This leads to a predictable, reliable process for generating the final code, which makes it perfect for building those big, complex, mission-critical systems.
So we've gone on quite a journey today, huh? From the old school way of manual coding all the way to this wild new world of AI-driven modeling. And as AI starts to do more and more of the heavy lifting, it leaves us with one last big question. What is the new role for human creativity in all of this? What's our unique contribution to building the future? That's a question that's going to define the next chapter of innovation, and it's definitely something we should all be thinking about.